Alright, so in this video, I'm going to be teaching you guys how to solve the equation 1 to the power of x is equal to 2. Now, I know what you may be thinking. 1 to the power of any number is itself 1. So how can 1 to the power of a number equal 2? Well, there is a method to solving this. So first off, let's take the natural log or ln on both sides. So I'm going to do ln 1 to the power of x is equal to ln 2. Now, if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this can equal b times ln a. So in this case, I have ln 1 to the power of x, and I can move x to the front, so I get x times ln 1 is equal to ln 2. Now, ln of 1 is equal to 0. So I get x times 0 is equal to ln 2, meaning 0 is equal to ln 2. However, ln 2 is equal to 0.693, so this is false. So this method does not work, the usual method of solving exponential equations. Now what I'm going to do is use an important formula known as Euler's formula. So this formula states that if I have something in the form e to the power of I times theta, this is equal to cosine of theta plus I times sine of theta. And I know this may seem a little confusing right now, but let's walk through it. So what if theta is equal to 0? Then this means that I got e to the power of I times 0 is equal to cosine of 0 plus I times sine of 0. And cosine of 0 is equal to 1, and sine of 0 equal to 0. So I get theta is equal to 2k pi. Now, if this is true, then e to the power of I times 2k pi is equal to 1. So, because this statement is true, then doesn't this mean that our original equation was 1 to the power of x equals 2, and this is equal to 1. This number right here is equal to 1. So we can say that e to the power of I times 2k pi to the power of x is equal to 2. All I did was substitute in that for 1. Now, if we solve for this, we should get our variable x. So what I'm going to do is I'm going to do the same thing I did the first time. I'm going to take the ln, or natural log, on both sides. So now I get ln of e to the power of I times 2k pi to the power of x is equal to 2. Now, if I have something in the form ln a to the power of b, this is equal to b times ln a. So I can move x to the front, and this is going to equal x times ln e to the power of I times 2k pi, which is equal to 2. Sorry, ln of 2. Now from here, this is the same thing as I times 2k pi times x times ln e, because I can again use the natural logarithm formula and bring this to the front. And this is equal to ln of 2. And if you guys already know, ln of e is simply equal to 1. So now I get I times 2k pi times x is equal to ln of 2. Now if I divide both sides by I times 2k pi, these two cancel out, and I get x is equal to ln 2 over I times 2k pi. Now I'm going to multiply both sides by I over I, which is equal to 1. So now I get x is equal to ln 2 times I over I times 2k pi times I. And I times I is I squared, and I squared is equal to negative 1. So now I get x is equal to negative I times ln of 2 over 2k pi. So this is my answer to this equation. Alright, so in this video, I'm going to solve an interesting exponential equation. So my equation is 100 to the power of x is equal to 400. And I want to find the value of x. So we see that x is going to be in between 1 and 2, because 100 to the power of 1 is 100, and 100 to the power of 2 is 10,000. So it's going to be more closer to 1 than it is 2, but it's going to be somewhere in the range of 1 and 2. So to solve this, what I'm going to be using is logarithms. So I'm going to first start by taking the log on both sides. So I get log 100 to the power of x is equal to log 400. And if I have something in the form log a to the power of b, I can move this exponent of b to the front, so I get b times log a. In this case, I have log 100 to the power of x. I can move x to the front, so I get x times log 100 is equal to log 400. Now, I'm going to take the log of base 100. So, log base 100 of 100 is just 1. And log base 100 of 400, well, 400 is the same thing as 100 times 4. So I can rewrite this as log base 100 of 100 times 4, which is equal to log of 4 over log of 100. And I have 1 plus this because of this. So now log of 4 is the same thing as log of 2 squared. And log of 100 is the same thing as log of 10 squared. So I can move the 2 to the front and the 2 to the front over here. So I get x is equal to 1 plus 2 log 2 over 2 log 10. These two cancel out, so I get x is equal to 1 plus log 2 over log 10, which is equal to 0.301. So x is equal to 1.301.